Good morning, students. So we were discussing chemical bonding and molecular structure, in which we had seen Lewis electron dot structure, Lewis symbols, how molecular structures are shown using the electrons in the valence shell by putting dots around the atoms. Then we had seen valence bond theory and its relation with the hybridization of molecular atomic orbital to form hybrid orbital. Again we had seen that after hybridization, how the hybrid orbitals change their shape, according to which the shapes of molecules can be known. Then we came to know about the drawbacks of valence bond theory, in which the bond parameters were not very well quantified, like what will be the bond angle, what will be the bond length. These were not very well quantified in that. This we had discussed so far. Today, after finding out drawbacks in the valence bond theory, how Vsepr theory, that means valence shell electron pair repulsion theory, will help us to determine the shape and structure of the molecules will be seen by us. So today's topic is valence shell electron pair repulsion theory. The best part of this theory is that each of these words will give you the hint about the postulates or the main points of this theory. What does it say? It says that it is the valence shell's electron which determines the shape and structure of the molecule, and the electron pairs, they repel each other. Due to their repulsion, they arrange themselves in such a way in the space that minimum repulsion is experienced. Just like if many students will be put in one classroom, then there will be repulsion and you will try to find your own comfortable place. Similarly, when many electrons are there around a central atom, they try to orient themselves in the space in such a way that there is minimum repulsion. Okay, the first point is then polyatomic molecules. Poly means many. Polyatomic molecules, that means molecules containing atom more than 3 or 3. Polyatomic molecules with 3 atoms or more has a central atom whose valence electrons are paired up with the valence electrons of surrounding atoms. Example, you have seen phosphorus pentachloride. It has 5 electrons and chlorine has 7 electrons. So see, each of these chlorine atoms are able to complete its octet by sharing electrons with the phosphorus. Now since we are not discussing about octet theory, so although there is 10 electrons around phosphorus, it comes under the condition of drawback of octet theory. You can again recall that octet theory had a drawback, that even octet were extended or octet were not achieved, then also molecules were stable. So in phosphorus you see that there are 10 electrons around it, but still it is stable. And in case of fluorine, 8 electrons are obtained by sharing. This is a polyatomic molecule which has 3 or more than 3 atoms. Central atom is sharing its valence electron with the surrounding atoms, and surrounding atoms are pairing up with their valence electrons with central atoms. So in this way electron pairs are made. These electron pairs, since they are negatively charged particles, they are like charges, they repel each other. Due to this repulsion, they experience a repulsive force, due to which they try to stay away from each other. Now, in an attempt to stay away from each other, they orient themselves in such a shape so that minimum repulsion is experienced. So, you will find that these 3 electrons will be in one plane, these 3 electron pairs will be in one plane, a triangular equatorial plane, and one chlorine will be above the plane and another chlorine will be below the plane. Since this is not a solid bond, I will make it with dotted lines. So this shows that it is equatorial plane, equatorial trigonal planar plane. This is the bond. This bond is above the plane and this bond is below the plane. Now since more electron pairs are there in the equatorial plane than the axial plane, the equatorial electron pairs repel the axial PCl bond and they become long. In this way we can explain the difference in the bond length of the same molecule. See, in the same molecule all bonds are PCl covalent bond. But why the axial bonds are longer? Axial bonds are longer because the electrons in the equatorial plane are more in number, and these lone pair of electrons which are not bonded, they repel the electrons on the chlorine above and below the plane. So in this way Vsepr theory was able to explain the bond length also and even bond angle. We will come to that. Before that, we will write, this was first point. Second point, the electron pairs. How many types of electron pairs? Either bond pair or lone pair. Both bond pair or bonded pair and lone pair. Experience inter-electronic repulsion. Inter-electronic repulsion. इंटर मीन्स आपस में, है ना, जैसे इंटर स्कूल होता है, इंटरनेशन होता है, इंटरनेशनल होता है, वैसे ही इंटर इलेक्ट्रॉन के आपस का रिपल्शन. इस रिपल्शन के कारण क्या होता है? द इलेक्ट्रॉन पेयर्स ट्राइज टू स्टे अवे फ्रॉम ईच अदर. द इलेक्ट्रॉन पेयर्स एक्सपीरियंस इंटर रिपल्शन. एज ए रिजल्ट they orient themselves. What is the meaning of orientation? They orient themselves, they arrange themselves in the space in such a way. Orientation means arranging oneself in a particular manner in the space. Like if I do like this, what am I doing? I am orienting myself like a swimmer. Okay. If I do like this, then I am orienting myself like a skydiver. So how am I arranging in the space, in three-dimensional space? How I am arranging myself is called as orientation. So the bonds, they orient themselves in the space three-dimensional space in such a way that the inter-electronic repulsion can be minimized. The electron pairs, bonded pair and the lone pair, both, experience inter-electronic repulsion. As a result, they orient themselves in such a way that the repulsion can be minimized. Now, what is the order of experiencing the inter-electronic repulsion? The order of inter-electronic repulsion is like this. The order of inter-electronic repulsion or electronic repulsion is lone pair, and lone pair repulsion will be maximum, because they have nothing to do other than repelling each other, because they are not bonded. So their magnetic moment is not nullified. Hence they will repel maximum. After that, lone pair and bond pair. And after that, bond pair and bond pair. So we will find that two bond pairs will be close to each other, but two lone pairs will be far apart. And lone pair and bond pair will be somewhere in between. See this bond pair here and this bond pair here. What angle are they making? They are making 120 degree, because they have lone pair also and bond pair also. So this lone pair and lone pair are repelling each other. So in the equatorial plane, it is forming 120 degree. But since this is repelling these two molecules, this chlorine atom and this chlorine atom, from the equatorial plane, so this bond elongates, it goes far away, and this bond angle is actually 90 degree. That means if you put one stick over a triangle, how will it look like? It will look like 90 degree. So these are the three important points related to Vsepr theory. In short, we call it as Vsepr theory. But still there are some limitations, okay? Where there will be law, there will be exceptions, and due to the exceptions, some limitations will be there. Limitations of Vsepr theories are like this. Before that, I will give you a few more examples. Let us take two examples more. In case of methane, we had seen the hybridization, it was sp3. So it was orienting itself in such a way that there was no lone pair repulsion. So in the place it was having an angle of 109 degree, 28 minutes. But in case of ammonia, there was a lone pair and three hydrogen atoms were there. That is why its bond angle was lesser than 109 degree, 28 minutes. Both the structures are tetrahedral structure. It has tetrahedral shape also. Tetrahedral shape as well as tetrahedral structure. But in case of ammonia, structure is tetrahedral. But shape is trigonal pyramidal. Base is trigonal and one nitrogen is above the plane. Shape is trigonal pyramidal. One question should rise in your mind, that what is the difference between shape and structure here? See, if I will take out all the bricks from this classroom, then the framework will be the structure. But after putting the bricks, the shape may be different. There will be a rack, there can be some kind of ventilators, there can be some kind of beautifying structure, there can be a wardrobe, that gives the shape. Okay. So The structure is tetrahedral. That means if one H plus ion comes, it will become, its shape will also become tetrahedral. But basically its shape is trigonal pyramidal because here there are no atoms, only electron is there. So if you will take out the X-ray picture of ammonia molecule, it will look like trigonal pyramidal, not tetrahedral. But if you will take out the X-ray picture of NH4, just like CH4, then again its shape and structure will be same. So structure gives the provision to the shape, and shape is found when there are real atoms around the central metal atom, or central atom basically. So this was one thing. So here what you see that only bond pairs are there, so they are oriented in a very relaxed manner, but here bond pairs are there, so they are not relaxed, they are forced to droop down. As a result, the bond angle reduces from 109 degree 20 minutes to around 107 degree. So see, we are able to quantify the bond parameters with the help of Vsepr theory. Although there are no mathematical formula with which we can find out these angles. These angles are found out by experimental method. So this will be one of the drawbacks of Vsepr theory. Now I will erase this and I will jot down the limitations of Vsepr theory. After this teaching, I will also send you the animated picture which will give you a visual treat to understand how electrons repel each other. Because with chalk and talk, I will not be able to tell you or show you so well as it can be done with the help of animation. Okay? In case of animation, what happens? Small particles are programmed to be shown in the form of balls, moving balls. So that will also help you to understand further. Now we will see limitation. Limitations of, now I can write Vsepr theory. Vsepr theory. First, it failed to explain a few structures of complex anions of B block elements. I'll give you a few examples of this. Like selenium hexachloride 2 minus. Second, titanium hexachloride 2 minus, and bromine hexafluoride 1 minus. See here how many electron pairs are there around bromine. Bromine has 7 valence electrons. Fluorine has 7 valence electrons. Then there are 6 fluorine atoms, so multiplied by 6 plus 1 electron here. So with these 1 electrons, that is equal to 42 plus 7 or 42 plus 8. With 50 electron pairs, according to Vsepr theory, its structure should be pentagonal bipyramidal. But their structure is found to be is found not to be pentagonal, bipyramidal in X-ray diffraction methods. X-ray diffraction method is just a method to find out the structure of molecules experimentally. So theoretically it comes out to be pentagonal, bipyramidal, but in reality with experiments it was found that their structure is not pentagonal, bipyramidal. This was one limitation. Another limitation was of justifying the structure of isoelectronic species. Example. Second limitation, it failed to explain the structure of isoelectronic species. Example, say IF7. It has got 7 electrons and this has also got 7 electrons and multiplied by 7. So how many are there? 49 plus 7 equal to 56 electrons. And if I take tellurium fluoride ion, tellurium belongs to which group? Group 16. Oxygen, sulfur, selenium, tellurium, polonium. So tellurium will have 6 electrons plus 7 into 7, 7 valence electrons multiplied by 7 foreign atoms and plus 1 for 1 electron here is also equal to 56. So although IF7 is pentagonal, bipyramidal, but TeF7 minus is not pentagonal, bipyramidal. It is little distorted. It was found that its shape was distorted by X-ray diffraction method. Hence, Vsepr theory was not able to explain these two facts. There are a few more facts of limitations of Vsepr theory which you will learn when you will go through the coordination compounds chapter in class 12. As of now, these two are more than enough for you to know. Thank you.